Welcome to the project demonstration of smart renewable energy roads with wireless electrical based charging system for EV vehicles. So here the main application of this project is we are going to do the electrical vehicle charging system based on the wireless power transmission, and to do that we are going to making use of a battery to convert DC to AC conversion. And when we talk about the battery which can be rechargeable, so we can recharge this battery pack in two ways, which is renewable sources and non-renewable sources from the grid whenever these renewable sources not providing the sufficient power to charge a battery pack. So here the renewable sources like wind and solar. So when the sufficient power and current available from these two sources, the battery will get fully charged in a duration of 4 to 5 hours with help of this charging circuits. And when there is no sufficient power available from these two sources, we can charge this battery pack with help of our transformer, which is getting the power supply from the grid. So once we are on the transformer, this charging light indicated the battery is charging. As of now, the low intensity from the solar panel, we can see the low light intensity from this solar panel section, and whenever the wind available, so we can see the charge indication on the charging circuit. So from these three charging circuits are connected to the three sources. One is a transformation for the grid, and wind and solar. So output of these three charging circuits is input to the 12 volt 1 amp rechargeable battery pack. So this battery pack consists of three 4 volt 1 amp batteries are in series. So we'll get 12 volt 1 amp DC output. So with the help of this switch, we can on the charging circuits, which is used to provide the wireless power transmission through this coil. So here how this wireless power transmission works. So generally we are getting the 12 volts of 230 volts AC input, which is of 50 hertz, and output of this transformer is 12 volts of AC of 50 hertz only. There's a low frequency can't provide us the sufficient EMF signal to the copper coil. So for that purpose we are going to convert AC to DC with the help of this charging circuits, and that will be stored inside this battery pack. And from there, conversion of DC to AC with the help of this IC, which is convert 12 volts DC to 12 volts of AC of 125 kilohertz. Then the high frequency will provide us the maximum EMF around this copper coil, which is the around region of 5 centimeters. And when we place the secondary coil, this will get induced. The induced EMF will be converted into the voltage with the help of this circuit, which is used to convert AC to DC, and the DC is input to the load. So here the process is like AC to DC to charge a battery from the grid, and DC to AC for required frequency to the coil, and from there the receiving coil will be received that, and that will be converted AC to DC again here. So this is the process of current and power flow in our project. So these three charging circuits look like same. So let me explain the one charging circuit of 4 diodes, which will convert AC to DC of pulsating DC, and filtration to remove the pulses provide as a periodicity of voltage to charging of the battery pack. And but here when we are providing the DC input, then these 4 diodes will acting as a direction controller, nothing but. So when it rotates in clockwise rotation or counterclockwise rotation, so it will rectify that to the plus to plus and minus to minus. Same for the solar input also, which is acting as a polarity corrector. Means when we correct the solar panel reverse polarity, then that will be rectified with the help of these diodes. So let us check the demonstration. Yeah, coming to the ratings, this is the 12 volts 1 amp transformer, and 12 volts 20 watts of dynamo, 12 volts 3 watts of solar panel we are using here, and 12 volts 1 amp is the battery charging circuit. So when we on this, there we can see the light indication. And when we place the secondary coil, as of now the EMF will be generated around this coil. When we place the secondary coil, then it will get induced, and we can get the power from this load. So we can see that this will be directly connected to the battery to charge this. So the main application of this wireless power transmission is there is no contact base, so that there is won't be any short circuit or any fire accident will occur while charging the battery pack. And moreover, which is very safe for the drivers, when we are charging electrical vehicle, no need to get down from the vehicle, directly just drive the vehicle to this copper coil, then automatically it will be charged. In real time we will place a number of copper coils on the road. On the go only the vehicle can get charged. Right, thank you.